Hello Techie guys, welcome back to Techie Uday. Today we are going to solve one more Leetcode problem. But wait, before going to that, if you are enjoying my videos, if you like the way of explanation, the visual animations, do like the video and subscribe to my channel to keep me motivated to do more interesting problems like this. So what is the problem today and how we can solve it? Let's check it out. Right, this is the problem that we are going to solve today. Problem 2598 from Leetcode, smallest missing non-negative integer after operations. The problem says the smallest missing non-negative integer. It means non-negative, we can highlight here. Non-negative can be 0, 1. We need to find 0 or 1 or 2 or whatever the non-negative integer that is missing from the given input, but not directly. It is after doing certain operations. What are the operations that we are allowed to do? Let's see in the description. So we are given a 0 indexed array nums and integer value as value. In one operation you can add or subtract value from any element of nums. You are allowed to add or subtract the value from any of the elements from the nums and any number of times. There is no restriction on that. For example, if nums is 1, 2, 3 and value is equal to 2, you can choose subtract value from nums 0 and you can make the values like this. So 1, 0, 1, 2, 3, you subtract 2 from 1, it becomes -1, 2 and 3. So that operation is allowed n number of times. The MEX, what is the MEX? Minimum excluded from an array is the smallest missing non-negative integer in it. So they are defining the MEX here. What is the MEX? MEX means the minimum excluded. That is the minimum, the smallest number of non-negative integer missing from the array. That is what we need to find out in this problem. So let's take an example here. We have the nums of array 1, -10, 7, 13, 6 and 8, and the value here we have 5. So what is minimum max? So what is the max value we need to find here? How we obtain 4 as an result? One can achieve the result by applying the following operations. They are explaining the operations that we can apply on the input. Add a value to nums1 twice to make the nums like this. So if you add 5 to this will becomes 1, 0, 7, 13 and 6 and 8. So in the same way, if you do the operations, we can obtain this array. So how this is obtained and why it is like that, explain you in detail, but let's understand the example first. So the max is 4 because in this array we have 0, so 0 is not missing. We have 1 is not missing, 3 is also there, 2 is also there. So what is the value, minimum smallest non-negative integer value that is missing here from the final array? That is 4, right? So we need to return that result. This is what the problem statement is. How these operations are calculated and why only those numbers we are selecting, that I'll explain you in detail. So if you really liking this, like the video right now. So take the second example. 1, -10, 7, 13, 6 and 8. Almost same example, but here the value is 7. In the same way, we can after performing any operations, we can obtain the max value as 2. So that is the maximum value of max we can achieve. So how we can solve this problem? If you understand the problem statement, then we can go for, if you understand the problem statement, then you can go for the solution approach. Let's see how we can solve the problem. Here in the given example, forget about this explanation. This doesn't add any value for us. This just to understand what is the problem is. If you are given input, if all the numbers in the array are positive, if all the elements, all the numbers of an array are positive, is it possible to find the max just by looking at the array. For example, if there is no -10 here, if there is a 2. Can you see the max value directly here after performing the operations? In the sense, if the value is 2, forget about the operations. If you minus, plus, so let's see the significance of value also here. On seeing this input, none, -10, 7, 13, 6 and 8 and the value 5. If the elements in the array all are positive, can we identify the max value? Even then it is not directly possible because of the constraint, like we can add or subtract the values. So what approach we can follow for this problem? The first approach is using the value here, convert all the numbers into non-negative values. How we can do that? On seeing this, any input, what is the maximum possible max of any given array? Like, for example, take an array like this: 0, 1, 2, 3, 4, 5. What is the maximum? What is the max of this? Here we have all integers. 0 is there, 1 is there, 2, 3, 4 and 5. So what is the max? What is missing? That is 6. If we have 6 here inside it, so what would be the max? It would be 4. So if any number below 6 is missing, then it is a max. If no elements are missing, then the length would be our max. So the possible max value, the maximum possible max value is the length of the array. So hope this point is clear. The maximum possible max would be the length of the array. So the max value cannot grow more than the length of an array. So we use this point to calculate the frequencies of the numbers. We use it later in the solution. But park it aside as of now. The point here is the maximum max possible value is the length of the given array. Right. Now we have given a value here. We can use this value to make our input all values less than that value. So that is, by using this value, we will go with what is the maximum possible level of operations. If we do maximum possible level of operations like on the given array, then all the values become positive numbers and less than the given value. For example, take this. If the value is positive and it is less than 5, so no problem. Here take this. The value is negative. If we add 2 times 5, this becomes 0. Here the value is positive but it is greater than 5. If you subtract 5 from this 7, this becomes 2. Here take this. The value is positive but it is greater than 5. So if we subtract 5 2 times, this becomes 3. And here we have 6. If we subtract 1 5, it becomes 1. Here it has 3, 8. If we subtract 5 from here, it becomes 3. So if we perform operations based on the value, we can make all the elements in the array less than the value given in the problem. So this is our first step. What is our first step? To convert all the given numbers to non-negative numbers and to make all the numbers less than 5. That is our first step. Right? But how can we convert all the numbers into a non-negative value? Here it is simple input that you can easily calculate. But how can we convert all the numbers into a non-negative numbers? We can convert to non-negative numbers by using modulus operation. Let's see that in our visualizer. This is our visualizer. In this visualizer, we have the given number array and the value as 5. Let's take it. Generally, any number can be converted to non-negative number by taking the modulus of the value. By taking modulus of a number, we can convert any number into a non-negative number which is less than that number and also positive number. For example, let's take the x value. If any value like this x value is 45 and the value is 5. So by using these two numbers, we can represent minus 45 as 0 because it's like a type of hashing technique, like grouping, like that. So if we represent minus 36 as 5 using the formula like this, x mod value in the sense 36 mod value is minus 1 plus the value plus minus 1 plus 5, how much? It's 4. So again mod value that is for positive numbers. Let's see that. So that becomes 4. So any negative number or a positive number, we can make it non-negative and less than the given value by using the modulus operator. So we use this as our key take in our problem. So any number, take any number that is becomes a non-negative number like 0 or 1 or up to 5, we can get the numbers. So all the numbers we can represent below 5. Any number we can represent below 5 like this, and non-negative like this. So we can convert any number to a non-negative number that is less than the given value by using the modulus operator. So by using this formula, like 43, how this formula helps? 43 mod 5 is 3, plus 5 becomes 8, and again mod gives you 3. So even it is positive, we'll get the correct corresponding non-negative number. Even if it is negative, we'll get the corresponding non-negative number. So this formula is very crucial while solving this problem. Hope you understand how we can convert any number into a non-negative number by using this formula. So let's go to the next step in the solution. So the first step, we need to convert all the numbers in the given array to the corresponding non-negative numbers by using the formula that we have discussed earlier. Convert all the numbers in an array to a non-negative numbers using this formula. So start with the first one. Using this formula, you can convert that to non-negative. Then minus 10 corresponds to 0. You can update that value. And 7 non-negative becomes 2. Update that. And 13 non-negative becomes 3. Then update that. 6 non-negative becomes 1. Update it. 8 non-negative becomes 3. Then update it. So this is the resultant array that formed after performing the maximum level of operations that we can do. There is no other operations possible to subtract or to add without breaking the constraint, like it should not become 0. If we subtract the value from any of these numbers, that becomes negative. If you add value to any of these numbers, that grow more than the value, and there will be a scope of subtracting the value again. So this is the maximum resultant array that it is possible to make all the numbers positive and the value less than the given value, right? So with this array, is it possible to find the MEX directly? And on seeing these values here, we can directly say 0 is there, 1 is there, 2 is there, 3 is there, but 4 is not there. So the MEX value is 4. But since the input is very small here, we can able to say that. But to solve this programmatically, just take the MEX value 0 and start from here and search in the array whether 0 is there or not. And then if 0 is there, search for 1. If 1 is there, search for 2. If 2 is also there, search for 3. If 3 is also there, search for 4. And 4 is also there in the given array. After conversion, search for 5. So continue this process till we obtain the value which is not there in the given input after performing the operations. So this is the array that is after performing all the possible operations. So in this array, we need to search for the MEX. So search for the MEX. So if you take directly, like if you do linear search, it will take again so many times to run. So to optimize it, we'll use a counter. So it will be easy for us to search in the array in O of one time. So to make it easy, we take a counter to keep the track of all the frequencies in the resultant array. Let's take the counters and update the counters starting from index 0 to and update the corresponding counters. Let's start. So counter of 1, increment it by 1. We have 1 0 in the resultant array, so increment this by 1. We have 1 2 in the resultant array, so increment it by 1. 3 we have, so increment 3 by 1. And we have again 1, so increment 1 by 1. It becomes 2 now. We have one more 3, so increment this by 1. It becomes 2 now again. So this is the valid counters of the given array. Why counters are required? Counters are required to just optimize the approach. We can perform the linear search on the given resultant array, but to optimize the approach, we have taken the counters. Right. Now start from MEX 0 and check the values of the MEX in the counter. But we need to check MEX modular value, because For example, if the array is like this 0, 1, 2, 3, 4, 5, 6. If the array is like this, what is the max value? It becomes 7. But the value given here is 5. In the counters, we have only 5. We have only 5 counters. So how we can do that? We need to search for MEX modulo value in the given. Why we converted all the numbers to below the given value? Why we converted this? To make it possible to search for the MEX with the operation MEX modulo value. If we do MEX modulo value, then even it is 5, the 5 becomes 0 because MEX mod value 5 mod 5 becomes 0. This becomes 1. So it corresponds to this. So since the counter is greater 1 or 2, we can decrement the counter, indicating that the value we have encountered already. So to make that possible, we need to calculate MEX mod value and update the counters accordingly. Let's see that in action. Take the MEX value 0. Start from 0. The MEX value, we have 0 in the counter, 1 in the counter. So update the counter to 0. It indicates that we have already found 0 in our resultant array. So now increment the MEX by 1. So since 0 is found in the array, we'll search for 1. So the counter of MEX mod value is 2. So you have 2 ones. So to indicate that we have already searched for 1 MEX and searched for 1 and we found that 1, decrement the counter by 1. So if any other value that corresponds to 1 finds in the given resultant array, it is clear that we have already used 1, so we don't get any wrong results. So now since 1 is also there, increment the MEX by 1. So now MEX becomes 2. Now search for 2. So 2, we already have 1, so it is also not our MEX value. So decrement to counter of 2 by 1 and update the MEX value by 1 and MEX becomes 3. Now search for 3 in the given array. Since we have 2 3s in the resultant, it is also not our MEX. So decrement the MEX counter of 3 by 1. Now it becomes 1. Now search for the 4 in the MEX. Now since the 4 is 0, that is our result now. Correct value for MEX is 4. So 4 is 0, that is missing from the given resultant array after performing all the operations. So we need to return 4. This is how we can solve this problem. Let's do a quick recap. The first step is convert all the numbers to a corresponding non-negative numbers. Then take the counters of all the numbers, how many times it was obtained in the given array. This step is just to optimize the search operation, that is not really required to find the MEX. You can directly search from here in the input for all the MEX to find the result. But to optimize, we take in the counters. So after counting all the possible numbers from the resultant array, start MEX from 0. Using the counter, search for the MEX value. Search until the counter of that corresponding MEX value becomes 0. So whenever the corresponding MEX value counter is 0, that is our required possible MEX. This is the algorithm for solving this problem. Let's see this in the code. As I said, this step we are converting all the numbers into non-negative numbers. But I have not added any formula here. But why? In Python, it will perform the operation and make the value as positive. So in Python, we don't need to apply the formula again and again. So using the modulus operation, the Python will take only the positive numbers, like it won't take the negative integers. It will perform that operation and the corresponding values will be treated. So formula is not required in Python language. So after converting all the numbers to the corresponding non-negative numbers, here we have taken a map as a counter. The counter will count for all the numbers in the given array. If it is result here, it will count how many numbers and the frequency of those numbers and store it in the map here. Now we take MEX as 0, and while if MEX modular value is greater than 0, it indicates that we have found that value in the array. If it is 0, then it is our required MEX. This is way, if that is not 0, we need to decrement the corresponding counter by 1 to indicate that we have encountered that possible MEX value in the given array. If counter value is 0, then we can directly return that MEX. This is how we can solve this problem. Hope you understand the problem very clearly. If you do not understand the problem, let me know in the comment section below. I will explain in much more detail in my coming videos. Hope you like this video. Do like the video and subscribe to my channel and stay tuned for more interesting problems. Let's submit the problem. Yeah, the problem has been submitted and all test cases are passed. So hope you enjoy this video. Hope you like the video. Hope you like the way of explanation. Or if you really like this, like the video and subscribe to my channel for more interesting problems like this. Thank you for watching. Have a good day. Bye bye.